Chapter 9. Analysis of data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data, usually quantitative, so that the reliability of conclusions based on the data may be evaluated objectively in terms of probability. There are two major types of statistics: theoretical and applied. Theoretical or mathematical statistics deals with the development, derivation, and proof of statistical theorems, formulas, rules, and laws, while applied statistics involves the applications of those theorems, formulas, rules, and laws to solve real-world problems. Role of statistics. 1. Statistics may indicate the central point around which a mass of data revolves. 2. They may show how broad or diverse the spread can be for a mass of data. 3. Statistics may reveal how closely or distantly certain features within the mass of data are related, as well as whether a relationship exists. 4. They may indicate the degree to which the facts might have occurred by mere chance, or whether there is a probability of their having been influenced by some factor other than pure chance. Establishment of categories. In establishing categories, 4 basic rules or guidelines should be followed. 1. The set of categories or values. The classification scheme for any one variable should be derived from a single classificatory principle, which is determined by the research question or hypothesis being investigated. 2. Each set of categories should be exhaustive. 3. The categories within each set should be mutually exclusive. Last but not least, the development of categories should be based in a sound knowledge of the subject matter and an anticipation of likely responses. After gathering needed data, it is imperative that these data are prepared for analysis. One way to prepare data for analysis is through coding. Example for these are the coding scheme for demographic variables. Some of the variables are gender, grade level, and age. The purpose of coding is to easily categorize and interpret the data in accordance to their respective categories. First, let's tackle the descriptive statistics. Descriptive statistics is a term given to the analysis of data that helps to describe, show, and summarize data in a meaningful way. It is a simple way to describe our data. Descriptive statistics is very important to present our raw data in an effective or meaningful way using numerical calculations or graphs or tables. There are 6 basic functions of descriptive statistics. 1. At the most basic level, the statistical analysis can indicate how many persons, objects, scores, or whatever achieved each value or fell into each category for every variable that was measured. These calculations, known as frequency distributions, are usually reported in tables. Common types of frequency distribution include simple or absolute, cumulative, percentage, and grouped distributions. 2. When it may be difficult to grasp the overall meaning of frequency distribution tables, pictorial representations can be used to portray a variety of characteristics of the cases or individuals with respect to the variable or variables measured. This process typically involves the use of one or more data displays as bar graphs or charts, pie charts, histograms, and frequency polygons. 3. Descriptive statistics are capable of characterizing what is typical in a group of cases. Such statistics, referred to as measures of central tendency, commonly include the mean, median, mode. The arithmetic mean is what is commonly called the average. It is the sum of the scores divided by the total number of cases involved. The median is the value of the middle item when scores are arranged according to size. The mode refers to the category or score that occurs most frequently. 4. Descriptive statistics can indicate how widely cases in a group vary. These statistics are known as measures of dispersion or variability. Examples include the range of scores, the highest score minus the lowest score, the mean deviation, the arithmetic mean of the absolute differences of each score from the mean, the standard deviation, the square root of the arithmetic mean of the square deviations from the mean, and the variance the mean square deviation. 5. Descriptive statistics can measure the relationship between or among different variables in the data. These are generally referred to as correlational or associational statistics. The sixth basic function that descriptive statistics can perform is to describe the difference between two or more groups of individuals. Inferential statistics. In inferential statistics, predictions are made by taking any group of data in which you are interested. It can be defined as a random sample of data taken from a population to describe and make inference about the population. Parametric test. Parametric statistics are based on assumptions about the distribution of population from which the sample was taken. 1. Z-test. This test, using standard scores, tests the difference between a group's results and the results that would be expected due to chance alone. Student's t-test. A test that can be used in place of the z-test where there is still only one group, but where, in contrast to the z-test, the standard deviation of the population is not known. Difference of means. A commonly used statistical test which utilizes t-statistic, and which determines if the statistical difference between the mean scores of two groups is significant. Analysis of variance. A statistical test which represents an extension of the difference of means test. Post hoc test. These test the statistical significance of difference between group means that have an overall difference calculated after an ANOVA or a regression analysis RA has been done. Pearson's product moment correlation coefficient R. It is referred to as simply the correlation coefficient. It measures the degree of linear association between two variables or the extent to which changes in one value correspond changes. Regression. Non-parametric statistics. Chi-square test X2. This test is useful for determining if a statistical Isofin relationship exists between two categorical variables. Mann-Whitney U-test. This is one non-parametric equivalent of the difference of means test, and is used to test for a significant difference bet to groups. Wilcoxon sign test. This test can be used instead of the Mann-Whitney when the data are not symmetrical. Spearman rank order correlation, or Spearman's. This is a non-parametric correlation coefficient that can be calculated for ranked or ordinal level data. Kruskal-Wallis test, a non-parametric alternative to analysis of variance. The requirements for using specific statistics of either kind tend to vary somewhat, and the researcher should carefully avoid using statistical tests inappropriately. That's all for today. Thank you for your time. See you to our next video.